Hello everyone, my name is David Glazer, and my mini project was about catching heart disease early, trying to build a predictive model using patient data to see whether or not those patients had heart disease. So the motivation for this project was that heart disease is the #1 leading cause of death for both men and women in the United States, and yet 80% of those cases are preventable. So studies have shown that the earliest possible prevention is the best. Finding the heart disease early will save many lives. So the best way to do that would be to use a model that can predict whether or not a patient has heart disease using their data. So let's take a look at that data. The data was collected throughout the 1980s. It was a collaborative effort between hospitals in Cleveland, Hungary, Switzerland, and California. So they collected all these patients' data. Some are simple, such as like their age and their sex, whether they're male or female. And there's some more complicated ones using maximum heart rate and cholesterol and their beats per minute, their heartbeats per minute. I'm going to put all of those features into my model to get the last column, the target. So in that target column, it's a binary outcome, whether it's a 1, meaning yes, that patient did have heart disease, or 0, no, it didn't. So we're going to see how accurate our model is. So like I said, our features involve qualitative and quantitative patient heart data to get a target of whether they do have a heart disease or they don't. So the model I selected was logistic regression. I figured that would be the best one using probability to see whether the patient does or doesn't have heart disease. So let's see how good our model was. Um, our model for our training accuracy was 86.6% accurate and 82.1 for the test. So these two matrices are called confusion matrices. They show how accurate your model is. So the columns, the 0 and 1 columns, are the truth, whether the patients really did or didn't have heart disease, and the rows are our prediction. So for example, in top left, we predicted that the patient didn't have heart disease, and they did not. And in the bottom right, we predicted that they did have heart disease, and they did. So the top left and the bottom right are correct. Those are where we predict accurately. The top right and bottom left are where our model failed. So in the top right, they did have heart disease, but we failed to catch it. And in the bottom left, we thought they did have heart disease, but they didn't. So the accuracy is that top left and the bottom right divided by all of our predictions. But it is pretty good because we see that for both the training and the test, our accuracy is above 80%. So now let's see what features our model found important. So in logistic regression, one way we can find the importance of each feature is by taking their weight and doing e to the power of that weight. So as you see in the right, the importance equals e to the power of weight. So according to our model, the two most important features are actually CP, which stands for chest pain, and thallic, which is a code word for doctors for maximum heart rate. So to me, I found that very interesting because those two features don't involve medical intervention. So patients who experience chest pain or unusually high heart rate, you don't need to go to the doctor to experience those things. So doctors can warn their patients at home that if they experience either of those side effects, those are early warning signs for heart disease. So it can be up to the patient to actually catch their own disease possibly. So thank you very much for listening, and hopefully if patients take this advice seriously, some more lives could be saved.